Today's lesson is on the law of sines. We're going to learn how to find sides and angles in non-right triangles using the law of sines. The law of sines is a rule or formula that's used for any acute or obtuse triangle to solve for missing sides or missing angles. The way that the formula works is that the side of the triangle, which they have with little letters, for example, the little a, the little b, and the little c, over the sine of the angle. The side is across from the angle on the triangle in each of these cases to use the law of sines. We typically don't use all three ratios that you see, which is little a over sine of angle A, little b over sine of angle B, and little c over sine of angle C. Typically you would have, for example, just this much of the problem written down. It really depends upon how many sides and angles you're given and which sides and angles as to how you're going to set it up. It's a proportion that you would set up. I've also included on here that if you take and flip-flop the numerator and denominator around, it still works. So the sine of angle A over little a equals sine of angle B over little b equals the sine of angle C over little c. These are the same formulas that both work the same way. When to use the law of sines? We use the law of sines when you have 3 dimensions of a triangle and you need to find the other 3 dimensions. They can't just be any 3 dimensions though, or you won't have enough information to solve using the law of sines formula or equation. So we use the law of sines if you're given the following: 2 angles and one side that's adjacent or next to the angles, 2 angles and their included side between the 2 angles, or what they call an ambiguous case, which are 2 sides and an angle. We know that this is not one of our triangle congruence tests that we use in geometry class for right triangles, so this one is not used as often. If it doesn't work with these two, the next rule we're going to learn is called the law of cosines. We would use the law of cosines rather than the law of sines to solve the triangle. Here's an example. We're given the angle B is 80 degrees, and notice that the side B is across from it is written with the same small letter b. If you always name the angle and the same name of the side, law of sines works very efficiently and quickly. So we have angle B is 80 degrees. We know that angle. I don't know the side across from it. I know angle A is 70 degrees, and we do know the side across from little a, which is across from angle A. So we set up the law of sines to find side B, what I need to find. It's similar in the idea that what do we know? 2 angles, and what do I need to find? One of the sides. Here's how this law of sines then would work. We take 12, the side, over the sine of the angle across from it, 70 degrees, set it equal to side B over the sine of the angle across from it, which is 80 degrees. Cross multiply. 12 times sine of 80 equals B times sine of 70. Now we're going to set up for the calculator similarly to what we did when we had to solve for x using the trig ratios for SOHCAHTOA. We have to get little b by itself. To do that, we'll take 12 times sine of 80 and divide by what's next to the b, which is sine of 70. The difference is on these problems, you're going to just use the sine, not sine, cosine, and tangent as we did for right triangles, and you're going to have more than one sine of an angle to type in your calculator. You might have to put parentheses around both sets of the degree symbols, and you might also have to put parentheses around the entire numerator. Look at your calculator and see if you can come up with the same answer and try it. The answer should be 12.6, and that's an approximation. Now that we have this side at 12.6 for side B, we can find one more thing, which is little c. We do know the angle C. There's 180 degrees in the triangle. We've used up 80 plus 70, 150 degrees. We have 30 degrees left for angle C. We don't have to solve that using any kind of the law of sines ratio. So we set up the law of sines now to find little c. Again, it's a proportion. On this one, I'm going to use 12 and sine a I'm going to use what I need to find. I just picked the a and sine of a because remember that b was an estimate, and we don't usually want to use an estimate of an estimate in a problem. I need to find little c. We put that over the sine of the angle across from angle or side c, which is angle c at 30 degrees. Cross multiply. 12 times sine of 30 equals c times sine of 70. Solve it. 12 times sine 30, we have to divide to get c by itself, so divided by the sine of 70. Put this in the calculator and then solve. We should get approximately 6.4. Here's another example. To solve for the missing sides or angles, we have to have an angle and opposite side to set up in order for it to work. The law of sines is based on knowing a side and an angle across from it. Notice on this one, we must find angle A first because the only side given is side A. So the angles in the triangle total 180 degrees, which means angle A has to equal 35 degrees. Here's our problem. We now have our 35-degree angle for angle A. The side across from it is side A of 30. We're going to first set up the law of sines to find side B. So we have 30 over the sine of angle A, sine of 35 degrees equals little b, what I want to find, over the sine of the angle across from it, or sine of angle B, which is 30 degrees. Cross multiply. 30 times sine of 30 equals b times sine 35. To get b by itself, we have to take and divide. So 30 times sine of 30 is still here, divided by the sine of 35 to get b by itself, and then put it in the calculator. Our answer is 26.2. Now that we have side B at 26.2, I have one more thing to find. We set up using the law of sines to find side C. I used the 30 over the sine of 35 again because I was originally, remember, given side A equals little c over the sine of 115 degrees. That's the side and the angle across from it that I want to find. Cross multiply. 30 times sine of 115 equals c times sine of 35 degrees. Solve for c. We have to take 30 times sine of 115, bring the sine of 35 to the other side by dividing it, and then put that in the calculator. So our side C is approximately 47.4. Let's say we want to find the measure of an angle B when we only know two sides and an angle that's given. I need to find one of the two other angles in the problem. Remember, in order to solve, we have to know, using law of sines, a side and an angle across from it. So this will show you how to find the measure of an angle in the problem using the law of sines. We set up the law of sines in the same way that we just went over on the other examples. 45 is the side, so this would be side little c, this is side little a, and this would be side little b. Remember that it gets the same name as the angle across from it. 45 is little c over sine of 35 degrees equals, I want to find angle B. 23 is the side across from angle B, little b is 23 over sine of angle B. Once I would know angle B, I can simply subtract from 180 to get the measure of angle A. Cross multiply. 45 times the sine of angle B equals 23 times the sine of 35 degrees. To get the sine of angle B, the whole quantity, we want one measure. Remember in our lesson that we did to find the sine, cosine, or measure of the angle, we needed to have this piece first. I need to divide by 45, just this piece. This is what I will then put in my calculator to figure out the sine of angle B. Once I know what that number is for this entire quantity, then remember to get the measure of angle B, I use the inverse sine key to get the measure of an angle. And that looks like this again, sine to the -1 power of whatever that number is that we'll find, and we'll find it to at least 4 or 5 decimal places. Use the inverse sine key and get the measure of the angle. My first task is to put this in the calculator, 23 times sine of 35 divided by 45. .2932. I'll round it to 4 places. Now we'll go to the calculator and put in inverse sine of 0.2932 to get the measure of the angle. Around 17 degrees is our answer. Remember, it's an approximation. We can round it to the nearest degree. So this angle is approximately 17 degrees. If you want, you can put this entire quantity with the inverse sine rather than the decimal in your graphing calculator, as long as you know how to use your calculator with correct parentheses to get the measure of the angle. That would just save you an extra step in the process of solving. So just remember, if you want to find the measure of an angle, get the sine of the angle first, then find the measure by using the inverse key. The only time you need to use the inverse key is when you have to find the measure of an angle. Otherwise, you can simply, on these problems, cross multiply and solve. And that's it for our lesson for today.